Hey guys, we're going to talk about the difference between prime numbers and composite numbers. Okay, so before we get into that, I just want to once again define what a factor is. Okay, so factors are numbers that are multiplied together to get a number. That's not a very formal definition, but hopefully one that's going to be easy for us to understand. So, for example, the factors of the number 8 would be 1 and 8, because 1 times 8 equals 8, and 2 times 4. So the factors of 8 are 1, 2, 4, and 8. Okay, because 1 times 8 equals 8, and 2 times 4 equals 8. So that's how you get the factors. Those are also all numbers you can divide 8 by, right? So a factor means you can divide it by the big number, and you will get a whole number answer, right? So we can divide 8 by 8, we can divide 8 by 4, we can divide 8 by 2, we can divide it by 1. 3 is not a factor, 5 is not a factor. You can't do 8 times 8 divided by 3, 8 divided by 5, and get a whole number for a quotient. Okay? So now the difference between prime and composite. A prime number means that the only factors are 1 and itself. Okay, so that means that the only numbers that you can divide by are either 1 or itself. So, for example, if we look at the number 3, the only things you can divide 3 by are 1 and 3, right? You can't divide 3 by 2 or anything like that. So 3 would be prime. Fun fact, the only even prime number is 2, because all other even numbers are going to be divisible by 2 or have a factor of 2. So 2 is the only even prime number. So if you have an even number and it's not 2, you can automatically click composite. Okay. 1 is not considered prime or composite. It's neither, because it doesn't really have 2 factors. It only has 1 factor, which is 1. So 1 is neither, and that's the only number that's going to be neither. Every other whole number is going to be either prime or composite. All right, so composite just means it has 3 or more factors. So it means you can divide it by something other than 1 in itself. So for example, 8, right? You can divide it by 2, you can divide it by 4. It actually has 4 factors. There's 4 things you can divide it by. There's a lot of people that say, well, how could you have 3 factors? Well, let's look at the number 9. What can you divide 9 by? 1 and 9 and 3, right? There's only 3 numbers you can divide 9 by. So it's composite because it has 3 factors. All right? Okay, when we are doing these problems, they're going to give you a number, and they're going to ask, is it prime, composite? And I think it might even ask if it's neither. Again, the only time it'll be neither is if it's 1. So when you're doing these problems, it's going to be helpful for you to use your divisibility rules. If you think back before Christmas break, we made those foldables where we wrote down divisible by 2, divisible by 3, right, and all those rules. I put them here on this slide so that if you don't have your divisibility foldable with you, I actually just Googled these. So if you don't want to write them down, or you could even pause this video, or you could take a screenshot of the video, or whatever you want to do. But if you don't do any of that, you can even just Google divisibility rules and they'll come up. But so these are going to be very, very helpful for you to figuring out if a number is prime or composite. 2 is easy. Just if the last digit is even, meaning it's 0, 2, 4, 6, or 8, the whole number is divisible by 2. Number 3, sorry. Divisible just means, again, just to remind you, divisible means that you can divide it by 2, you can divide it by 3, you can divide it by 4, and you'll get a whole number answer, quotient. So if a number is divisible by 3, that means you can divide something by 3 as long as the sum of the digits is divisible by 3. Example, let's consider the number, I don't even know, let's just make something up, 39. If I do 3 plus 9, that gives me 12. 12 is divisible by 3, meaning I can divide 12 by 3. So therefore 39 is divisible by 3, because the sum of those digits 3 plus 9 is divisible by 3. Okay. 4 tells you that the last 2 digits have to be divisible by 4. So if we have the number, oh, I also want to add or, the last 2 digits need to be 0, 0. If the last 2 digits are 0, 0, that's also divisible by 4. So if you had the number 500, that's divisible by 4. Also, if you had the number 336, 36 is divisible by 4. Okay. 5 should be easy. The last digit's either 0 or 5. 6, you're going to use rolls 2 and 3. 8 is not as helpful because the last 3 digits have to be divisible by 8. We don't know a whole lot of 3-digit numbers that are divisible by 8. However, if you had the number like 5,888, right? The last 3 digits are divisible by 8. 9 is similar to 3. You're going to add those up, add all the digits up, and that number has to be a multiple of 9. 9, 18, 27, 36, right? 10, it just has to end in a 0. Okay, I went through those quickly again. We did all that before Christmas break. All right, so I have a list of numbers here, and I'm just going to go through and explain whether they are prime or composite and why. So, 67. The first thing I do, well, actually the first thing I'm going to do is I'm going to go through my numbers, and I'm going to say if they are even, they're automatically composite because they're divisible by 2. So 62 right here, that is composite. It's an even number. I'm going to do this the easiest way possible. 530, it's even, and it's also ended in 0, so it's also divisible by 10. So it is composite. 2 is the easiest one to check. Okay, and that's it. After 2, I think the easiest one to check is 10, which we already used. And then I think the next easiest one after that is 5. So if the number ends in 5, it's divisible by 5. Meaning 5 is a factor. You could divide that number by 5. So those are composite because they end in 5. So the first things I would check are 2 and 5. After that, you want to check your 3 and your 9 because you do the same thing. So let's look at 67. If I take 6 plus 7, I get 13. That's not divisible by 3 or 9. Okay. Now, once you clear out all the even, so let me just put these over here. Now, there's a reason that we don't have a divisibility rule for 7, and if you remember me saying it in class, the rule for 7 is kind of confusing. It's just easier just to check. So first thing you should do is check 2 and 5. Those are the 2 easiest. Okay. After that, I checked 3 and 9. So I'm going to go through all my numbers and do 3 and 9. So 67 did not work. 41. 4 plus 1 is 5. Doesn't work. 157. 1 plus 5 is 6. Plus 7 is 13. That doesn't work for 3 or 9. 91. 9 plus 1 is 10. Doesn't work for 3 or 9. 19. 1 plus 9 is 10. Doesn't work. 87. 8 plus 7 is 15. Okay. So 15 is a multiple of 3, right? So that number is going to be composite. Okay. 293. So 2 plus 9 is 11. Plus 3 is 14. It's not divisible by 3 or 9. And lastly, we have 69. So 6 plus 9 is 15, which is a multiple of 3. So that is composite. You can divide that by 3. So check 3 and 9. Now, when we check 2, that is essentially saying we checked all even numbers. So if it's not divisible by 2, it's not going to be divisible by 4 or 8 or 6. It's not going to be divisible by any even number. So when you clear out 2, you're clearing out 2, 4, 6, 8, 10. All right, so really, okay, so we checked 2, we checked 5, we checked 3 and 9, and now all that's left is to check 7. Again, I said 7, you just kind of have to do the division to double check. All right, you also need to keep in mind if you have something that's divisible by 11 or 13, because those are prime numbers. All right, so 67, if I tried to divide that by 7, you should know your multiple of 7 up through at least 77, right? So 67 is not one of those multiples. So that's actually prime. 41, again, you should know your multiples of 7 up through 77. It is not a multiple of 7, so that is prime. 157. Okay, well, if you can't do it in your head, that's fine. You can do this division. 7 goes into 15 2 times. 7 doesn't go into 17. That is prime. It's not divisible by anything except for 1 and 157. That's kind of crazy, right? There's no number between 1 and 157 that when you divide them, you get a whole number. So there are very, very large prime numbers. All right, 91. Let's check that. 7 goes into 9 one time. 7 goes into 21 3 times. So that one actually works out. That is composite. It's a multiple of 7. Okay, 7 times 13 equals 91. 19. Not a multiple of 7, not a multiple of 11, not a multiple of 13. 293. So let's check that. 7 goes into 29 4 times. 7 doesn't go into 13 an even or a whole number amount of times, so that is prime. Okay. So again, as you're doing these problems, you're going to get one at a time. I suggest checking: is it divisible by 2? Is it divisible by 5? Is it divisible by 3 or 9? Check those together, because you're going to add the digits for both of those. And then you'll check, is it divisible for 7? So you really have to check 4 things. These 2 are really, really easy to check. This one you're just adding. This one you have to do some division. Okay, but it doesn't take long, as you can see from what I did. All right, now there's always a chance that it'll be divisible by one of these. So you may want to look into that too, consider that. But most of the time, these are the numbers you're going to be worried about. Okay, I hope that made sense. I can't wait to get back in the classroom and see you guys and be able to teach not through a computer screen. But we're getting there. We're almost done. So good luck. If you need any help at all, please let me know. I'm here.